Good morning, students. This is Mrs. Watson. Today we're going to talk about adding and subtracting rational expressions with unlike denominators. When the denominators are the same, it's easy because you just add the numerators. But when the denominators are different, you can't do that. So what we have to do is make the denominators the same. So let's look at some fractions as just an example to start with, because you've probably done this before. We think about what would the common denominator be of 5 and 10? I'm 5 and 2. Whoops, I gave it away. 10, right? So we would have to make this a 10. And the way we do that is to multiply this by 2. But we can't do the bottom unless we do the top, because then we're really multiplying by 1, aren't we? 2 over 2 is 1. And to make this 10, we have to multiply the top and bottom by 5 to get the bottom to be 5, right? So now I've got 2 times 4, which is 8 over 10, minus 1 times 5 is 5 over 10. And since the denominators are the same, now I can actually perform the operation. 8 minus 5 is 3. If that 3 had been something like a 2 or a 4 or a 6, I could reduce the fraction, simplify the fraction. All right, but since this is 3, 3 doesn't go into 10, and I'm done. Now when I look at one over here with variables in it, I got to think, what would the common denominator be? What would be something big enough so that 3 would go into it, x cubed would go into it, 6 would go into it, and if x cubed goes into it, obviously x does. So our common denominator here is going to be 6, because 3 goes into 6, 6 goes into 6, and x cubed. I sometimes explain this as being sort of like a vegetable soup, okay? And it's got a little bit of everything in it. So it's got to have enough in it, in the soup, that there's a 3 in the soup and there's 3 x's in the soup, okay? And it's got to have enough so that the 6's in the soup are 2 and a 3, all right? So the 3 was already there, so I have to put a 2 in there to get 6. And then I've already got 3 x's, so there's already an x in there. So this is big enough that if I were to divide both of these by that, they'd cancel out, right? And so now I got to figure out, what do I have to do to 3x cubed to make it 6x cubed? I have to multiply both sides by 2. Both sides, top and bottom, by 2. Over here, I got to say, well, what do I have to do to 6x to get it to be 6x cubed? I've got to multiply it by x squared. I need 2 more x's. And so these are tedious problems, but if you take it step by step, very slowly and very carefully, and you can read your own writing, it's not too bad. Okay, so my denominator is 6x cubed. Over here I've got a 2 times a 5, which is a 10. And here I've got a 7 and an x squared. And that's all I'm going to be able to do to this. That's it. I've combined it, but I can't simplify it in any way. And so that's the way it stays. I hope that makes a little bit of sense. Let's go see if we can do some that they get a little bit more difficult when these become binomials on the bottom, okay? So first thing I got to do is figure out what is my common denominator. Well, 6 and 8. I could multiply them together and get 48. That's kind of a big number. 24 actually goes into, both these go into 24, don't they? So I could say, okay, 24. And if you do 48, there's nothing wrong with that. It's just that at the end, you're going to have to reduce it. How many x's do I need in my denominator so that I've got at least 1 and I've got at least 2? Now, I don't have to add those together. I just need to have enough so that each of those can go into it. So x squared is enough here. Again, if you made it x cubed, okay, and you multiply this top and bottom by x squared and this top and bottom by x, that'd be okay. It's just that you'd have something to cancel out at the end. And so we like to do our math so we have the least amount of work possible. That's always a good thing in that. All right, so now, what do I do to 6x to make it 24x squared? I've got to multiply it by 4, and I've got to multiply it by another x, because it's only got one x, and it's going to need 2. Does everybody understand that 4x and 6x multiplied together is 24x squared? But I can't do something to the bottom unless I do it to the top. Same thing to the top. Then I come over here. What do I have to do to 8 to get 24? I have to multiply it by 3. X squared is already x squared, so that's all I have to do to that. All right. So now I've got 28 x, don't you love my handwriting here, plus 15. And there's nothing that goes into all these terms. Otherwise, I could simplify. You can't simplify this and say, well, 4 goes into both of those. You can't do that because of this guy. It'd have to be something that you could factor out of these two terms, and then it would cancel out for it to work. So 3 and 5, well, 3 goes into this, but it doesn't go into that. 5 doesn't go into this or that, right? So there's nothing that goes into all 3, so it stays that way. Over here, what would my common denominator be? Well, 40 would work, but 20 would be smaller, wouldn't it? 20x squared. And then to make this 20x squared, I got to multiply by 2x. I don't even have a mouse. I'm doing this on my laptop here today. So I'm using the little mouse pad at the bottom. Okay, and then over here, to get this to be 20x squared, I'm going to multiply top and bottom by 5. Okay. So, on the bottom, I got 20x squared, 20x squared. That's already done for me. Then I say 6x plus, minus 5. And there's nothing that goes into 6 and 5 and 20, so that's it. That's my answer. That's all I can do to it. Okay, now, when there are binomials on the bottom, it's a little more complicated, because my common denominator cannot be x minus 1 plus 6, okay? They're kind of, the minus signs and the plus signs, I like to think of them as being glued together. So my common denominator over here is going to be x minus 1 times x plus 6. Okay? I can't separate the individual terms from their, the variable and their letter. I can't separate those. They're like super glue. But now I can get a common denominator, and I can say, okay, what's missing out of this denominator? X minus 1 is there, but x plus 6 is not, right? So I'd multiply the top and the bottom by x plus 6. Multiply this by x plus 6. And you already see this could be a little more complicated. Over here, the x plus 6 is there, but the x minus 1 is not. So sometimes we get a little bit lazy and we don't write it on both top and bottom. Okay, we just write it at the top. But we know what we mean because we've already written it here. All right, so what is x plus 6 times x plus 2? Well, we're going to FOIL this and get x squared. 6x plus 2x. And I will combine like terms in a minute. Some of you that are ahead of me there. Plus 12. Okay, so that's the first part of it. And I got to be really careful because of that minus sign. Okay, so what I'm going to do to make sure I don't screw it up is I'm going to put a minus sign and then parentheses here. So I got 12x. So I got 12x. So see how that's going to become negative 12x when I distribute that negative sign from over here. So I got, or you can do it this way and say, well, it's like plus a negative 12. Say negative 12x. You can do it that way if you want to. Okay, so 12 times negative what is negative 12? Or if I've already distributed that. Now, here's a bad habit of mine, is I get to where I just don't write the denominator every time because it takes so long, especially when you're writing with the mouse. And so I get a little lazy and I just write the numerator because that's, after all, what I'm trying to get cleaned up here. So I got 8x. I'll just combine those two terms for now. Plus 12. And then I've got to distribute that negative sign. Or if you've already done the plus and negative, you might already have negative 12x. Which would be good. Either way, I really like the plus and then make it a negative thing, because then the negative sign gets carried to everything and you don't mess it up. Okay, it's so easy to miss that negative sign. I used to have a list of 3 most common ways people mess up a math problem, and that was one of them, was the carrying the negative sign across. Okay, I've only got 1x squared, so there's x squared. I've got an 8x and a negative 12x, so that's negative 4x. And then I've got a 12 and a 12, which is 24. Now, what do you think of the minute you see something like this? There should be something that pops into your brain instantly. You go, ooh, I wonder if it factors. Okay? Yeah, I would wonder if it factored. Okay? But on the bottom, see, I've got x minus 1. And I've got x plus 6. So one way you can sort of tell or kind of like pre-guess if it's going to factor is look at the denominator, because if it's going to factor, chances are something's going to cancel out with the bottom. Well, if you had an x plus 6 up here, you'd have to have an x plus 2 to get positive 12, wouldn't you? And x and positive 6 and positive 2 would be positive 8, and that's not right here. 6 and 2 sounds reasonable, okay, because 6 and 2 has a difference of 4 and multiplies to 12, but you'd have to have a negative 12. You'd have to have a negative 6 and a positive 2. So it's not going to factor the way it's written, okay, because they'd have to both be the same. If they're both negative, you wouldn't get negative 4. If they're both positive, you wouldn't get negative 4. So that's the way it's going to stay, just like